In this video, we're going to be looking at solving equations using graphs. Before we continue with this, you need to make sure you are comfortable plotting graphs. Here are two for you to quickly have a go at. Plot y equals 2x plus 3, and on the same pair of axes, plot the line y equals 7. Pause the video and have a go. The line y equals 2x plus 3 has y-intercept 3 and gradient 2. That means every time you go 1 unit across, you go 2 units up. And that means we get this line here. The line y equals 7 is simply the line where every single point has a y coordinate of 7. If you're not sure about any of this, go back to topic A9a. Let's have a look at the first question. We need to solve 2x plus 3 equals 7 by drawing appropriate graphs. Here's what we're going to do. We're going to plot the graph of y equals the left-hand side here. So we need to plot the graph of y equals 2x plus 3. Then, on the same axes, we're going to plot the graph of y equals the right-hand side. That means we need to plot y equals 7. Now, those are the ones we just used to warm up, so this is what those lines look like. Now we've plotted the lines, we need to look for where they meet, or where they intersect, to use the mathematical term, and that is at this point here. Now, remember what we're trying to do. We're trying to solve this equation. That means we are looking for the value of x that makes this true. We do that by reading down to the x coordinate of this point here, and that is 2. So the solution to this equation is 2. Now, why does this work? Well, think about it. We're looking for when 2x plus 3 equals 7. So here is the line y equals 2x plus 3, and what this shows us is all the possible values that 2x plus 3 can take for different values of x as you go along the x-axis. And we want to know when the value of 2x plus 3 equals the value of 7. And that happens when x is 2. So that's it, we've got our solution. However, we can just check this fits in with our understanding of solving equations using algebra. I've got 2x plus 3 equals 7. I want to isolate the x, so I'm going to subtract 3 off the left-hand side and the right-hand side first. That then gives me 2x on the left, which equals 4 on the right hand side, and the next thing I need to do to get to here is divide the left hand side by 2, which means I also need to divide the right hand side by 2. That leaves us with x equals 2, which confirms we got the correct solution using these graphs. Let's move on to the next question. Here's question B. What I need to do first is plot the graph of y equals the left-hand side, and then I need to plot the graph of y equals the right-hand side. So here's the line y equals x minus 1, and here's the line y equals 3x minus 7. See if you can spot the solution to this for yourself. Hopefully you've noticed this point of intersection, which means the solution is 3. So we write our answer as x equals 3. Remember, we can always check a solution to an equation by substituting it back in. If we substitute 3 into this equation, we get 2 on the left-hand side, and on the right-hand side we get 3 times 3, which is 9. Subtract that 7 and that will give us 2 on the right hand side. So we get 2 equals 2, which is indeed correct. So we've got the correct answer. Here's the final question. What we need to do is plot the line y equals this left-hand side. Now, if I expand that left-hand side, I get y equals 2x plus 4. Then I also need to plot the line y equals the right-hand side. So that will give me y equals 3x plus 9. See if you can plot both of those on a grid and use your lines to find the solution to this equation. Pause the video and have a go. Here's what you should have found. Here are the two lines that we needed to plot. They intersect at this point here. So the x value that satisfies this equation is simply going to be -5. So I write my solution as x equals -5. And again, we can check this solution by substituting this into the equation. If we substitute -5 into the left-hand side, we get -6. And if we substitute -5 into the right-hand side, we see that this is worth -6. So they are equal, which means we've got the correct solution.